In this video, we're going to go over Notebook C, Entry 3, just the first part of it. Today, we're only going to talk about kites, and then Monday, we'll do some stuff with trapezoids. So we're still dealing with polygons, just one specific kind, which is something called a kite. So Notebook C, Entry 3, Properties of Kites and Trapezoids. Don't write this little green part here, but you would start with this part where it gives the definition of a kite. So a kite looks very much like you would think a kite you would fly would look. And what it is, it's a quadrilateral, so it has 4 sides, and it has 2 pairs of congruent consecutive sides. What that means, oh, sorry, my thing is turned off here. Okay, had to fix my slider. But the 2 pairs of congruent consecutive sides, like this side AB, is right next to or consecutive to AD, and they are the same thing. BC is right next to CD, and they're the same thing. So the top, or like in this case the left 2 equal, and these right 2 are equal. Just like with parallelograms, we have a few facts that go with kites. And the first one is that a kite's diagonals are perpendicular. Perpendicular means that they meet at 90 degrees. So they make right angles. The diagonals are on the inside. So this here and this here makes 90-degree angles everywhere. So AC is perpendicular to BD. The second fact is that in a kite, exactly 1 pair of opposite angles in the kite are congruent. It's not, okay, angle A and angle C are not going to equal, because this is longer to get to C than that one was to get to A. It makes a different angle. So the only pair of congruent angles is B and D, because it has this short side, long side, makes the same angle. There's 1 pair of equal angles. Angle B equals angle D. The third thing is to find a kite's area. That's a formula where you just say half. Kind of makes you think of the triangle formula, half of base times height, but this one's half of diagonal 1 times diagonal 2. So half of whatever this diagonal is times this diagonal will give you its area. Once you get those facts, we'll talk over these couple examples here. And in this kite, you are given that you have an angle FEJ, F to E to J is 25. FGJ, F to G to J is 57. And you want to find angle GFJ. GFJ. And it looks like I made a mistake, and I went ahead and wrote it down. But how do I know that was 33? Well, by the first theorem, I knew that this diagonal and this diagonal met at 90 degrees. And then I noticed that this is just kind of like making a triangle right here. And in a triangle, I know that all of the angles have to add to 180. And I've already got 2 of them. I've got that this one's a 90. So I'm going to take 90 away from what I had available. That leaves me with 90 left. And that's where I picked up right here, that I have 90 left, but I have 57 that I've used. So I had to take 57 out of that. And how much was left for GFJ? Just 33. So that's how I knew that was 33. I treated it like a triangle. 180 minus 90 minus 57 equaled 33. Now angle JFE, J to F to E, I needed to find, and it looks like I accidentally wrote it down again. I wanted to find this angle, and I noticed that, hey, it's in a triangle right here. Well, I know that one's 90, and that one's 25. So I did 180 minus 90 was 90, minus 25 was a 65. So this angle up here had to be 65. Then it asks me to find angle G to H to E. Oh, so the big angle, it's like this one and this one. Which facts want to help me on that? Oh, one pair of opposite angles is equal, like this one and this one, which would mean that this big angle equals this big angle. So if this one's 65, this one's 65, this one's 33, this one's 33, and what would those two angles together be to make that big one? 65 plus 33, this angle had to be 98. Now, fair warning, we've been talking about Pythagorean theorem, which is a squared plus b squared equals c squared. Maybe on a problem or two, you might have to use Pythagorean theorem to find a missing side. Like if they gave you this one's 10 and this one's 7, they may ask you to find this one. And you'd have to treat it like Pythagorean theorem, where that's an A and that's a B, and that would be like C. That might pop up. I'm not 100% sure, but just in case. There it is. Once you have these notes down, we'll use these 3 facts to do today's assignment, which should be page 444, 3 to 6, 13 to 16, and 29. Properties of kites and trapezoids. We're just doing the kites part today, and Monday we'll finish with the trapezoids.